Welcome back to the Byrne-Wheeler Report, episode 15. This is part 2.
Okay, talking a little bit about some new XPUs. There's a startup called Etched, and they had put out a little bit about their technological approach. One thing that grabbed me when I looked at their description on their website of what they're doing is they talked about using lower power circuits because of, FCV squared. You have this square factor for power savings if you lower voltage. And at the same time, when I was looking at MediaTek's description of their ASIC business, one of their strengths they mentioned was around lower voltage circuits. Got me thinking.
Yeah. I haven't seen any details on Etch. And when you say lower voltage, are we talking like near threshold? Who knows? Okay.
Everybody's, I think people have figured out how to maximize hype and interest while firewalling off the relevant details. So I don't know. The other thing is they talked about having some kind of big share pool of memory, but it wasn't clear if that was virtualized because they still use HBM adjacent to their big digital chips, which have SRAM on them. So there's a little bit of hand waving going on still. The other notable thing is they were started by 2 or 3 Harvard dropouts, and they became Peter Thiel sponsored entrepreneurs. But again, you go to their website and you look at their staff. It's basically a super group. This guy who's been a CTO of Cypress, Mark Ross, and has a track record of achieving A0 silicon. This guy did platforms at Nvidia. This guy did software at Nvidia. So it's the face may be these young folks, but the actual engineering of this 400 plus person company is being led by some very experienced people.
Yeah, the software lead came from Google TPU team, and definitely have interesting mix of talent, including people with deep chip design and software design experience. The other big news in the XPU area was the kind of Broadcom OpenAI announcement of the Jalapeno ASIC without a whole lot of details, but the claim to fame was kind of 9 months from design. I think
design.
Yeah, from initial design. And at one point they used the word production, but of course what they really meant was tape out. So it was some point in the design phase to tape out was supposedly 9 months.
Yeah, again, a lot of deft manipulation of the hype. And, they said they used AI tools to help develop this. I've got to think that Broadcom had significant IP in the can that they're using, like the on-chip interconnect, probably. I mean, I guess they could go to Arteris for that. But whatever their granule is, just design these chips and verify them. I mean, unless you're building them from IP you're highly confident in that's already been verified, it's just the validation, the timing closure, all that would ordinarily take more than 9 months. And I don't think AI can really accelerate validation.
Well, I guess that's an open question and something that we should be paying attention to, because that is the long pole in the tent these days, right? And with these massive designs. So, but I mean, clearly Broadcom has a lot of IP in terms of the IOs, proven SerDes and other IOs. So it's really more the kind of digital core, and it's since we don't know really anything about the architecture, it's very hard to assess.
I did peer at the picture of Sam Altman and Hock Tan holding up the wafer, and if I interpret things right, zooming in, it looks like it's a reticle limited die, so it's going to be a big chip. I think maybe
these days it seems like reticle limited just means you fill the remaining area with SRAM, right?
Yes. So we'll see. I think they could have waited 3 months or whatever to get first silicon back and then said that they went from initial design to first silicon in a year. That would have been equally impressive. And if first silicon didn't work, they could have just buried it and not said anything. Because, big claims always need big proof. The proof's in the silicon.
Yeah, but I think Broadcom has a pretty good record on A0, so we'll see.
Yeah, but there could be logical, functional bugs.
Absolutely.
Like, hey, the chip works the way you asked it to. Don't blame us if it's a because I think back to the initial Tesla Dojo, I think it was a 2022-ish presentation they gave. And when I first came back, they only achieved 5% utilization. So they made changes to the system to improve that. But, the chip worked, but 5% utilization is not, really doesn't make for a viable system. By utilization, compute unit utilization while, executing a model. All right, another startup, Upscale AI, they secured some funding, right, Bob? How much was that?
Yeah, they raised an additional 190 million. I think they've raised 500 in total now, if I'm remembering the number correctly. It tells me that they've probably achieved a significant milestone with their so-called Skyhammer switch architecture. In the meantime, they're doing other things like building systems around Nvidia Spectrum X silicon, but really the scale up part of the story is their Skyhammer ASIC or internal chip.
They must have accomplished something to justify investors pulling the trigger and cranking them.
I would have to assume so. Even these days, when the numbers seem huge, I think that indicates that they've hit a significant milestone. Micron announced earnings, kind of blowout earnings, but there was also some interesting information about the business model.
Yeah, the big thing was they have these SCAs, these customer agreements, which are take or pay. Now, they have upper and lower bounds that the price can be within, but these customers signing up to them, they're going to pay Micron. So Micron's got guaranteed business for approximately the next 5+ years.
Yeah, it completely changes the dynamics of the traditionally cyclical memory market, right? It does kind of virtually guarantee that you're not going to see the kind of catastrophic collapses we've seen in previous cycles.
Yeah, and they're at 20% of their revenue or bookings now are covered by this, and their goal is to get to 50%. That's a big cushion that they have. So even if the bottom falls out, they're protected.
And I guess the flip side has been, there's been concern that the memory makers weren't investing enough from a CapEx standpoint. And of course, they didn't want to get ahead of demand. So this helps kind of lock in the demand so that they can then go spend the CapEx and break out of that cycle.
Exactly. And their near-term financials, their most recent quarter was really good. Their free cash flow was like $30 billion, which is about a little bit less than not the most recent quarter, but the prior quarter that Nvidia did. And considering Micron has to build fabs, that's just massive, massive cash.
Yeah, it's pretty amazing. And you can see there was also commentary around what's going on with pricing. So it's a very happy place to be right now.
So Oxmiq Labs is next on our list of things to talk about. This is Raj Kaduri's startup, is a noted GPU engineering leader, and company has articulated this pretty comprehensive vision, which started out as GPU IP and now goes much past GPU IP.
In what way? What else are they planning?
They will design chips for customers, including multi-die packages, and they will even work to help customers with system design and then pod design and even ensuring that they're helping with the data center construction and power provision. So comprehensive view about what they want to do. And as we noted before, with respect to modular, there's also a software angle where they'll provide enablement for software to enable GPUs based on their GPU IP.
Okay, sounds like an interesting company to watch going forward.
Well, let's turn to a couple CXL topics. I know Bob's CXL was an area you focused on quite a bit a few years ago, and then CXL kind of went into hibernation, and now it's coming out. The first thing being
back from the dead.
Back from the dead. And we've got Meta presented a paper on their Vistara chip, which is a fancy CXL controller. What are your thoughts on that?
Yeah, I'm not sure how fancy it is, frankly. After reading through the paper, it's I think a fairly straightforward CXL controller, the big deal is the ability to reuse DDR4 DRAM. And I mean, this is something I've heard about for years now, but a few years ago when DDR5 was cheap, there was very little motivation to go harvest DDR4 that had already been installed, given the OpEx required. And now suddenly with memory prices where they are, Meta in particular is motivated to try to go reuse DDR4 that was stranded in old servers. And so they've done this custom CXL controller, which basically has 2 DDR4 channels on one side and 16 lanes of CXL2, which is based on PCIe Gen 5 on the host side, and allows them to do basically memory expansion on the latest and greatest CPUs that have CXL support, but reusing the old DDR4 memories. Connecting the dots here, this sounds a lot like one of the Structera X products that Marvell announced 2 years ago now. And Marvell has been talking about what they call XPU attached design wins, which include both CXL program that they've mentioned, as well as a NIC program that they've mentioned. And not coincidentally, the NIC program is with Meta that's been disclosed. So it's pretty easy to connect the dots here and say that the custom CXL program at Marvell is also Meta, and so this is most likely a semi-custom version of the Structera X product that Marvell developed and announced a couple of years ago.
Yeah. And then the other CXL news was Panmnesia. Having a little amnesia here, trying to remember, but Panmnesia. There is more of a technical difference here, right? Because they are trying to loosen some of the constraints around how CXL can be deployed, right?
Well, so they talked about both a controller and a switch. And on the controller side, it's not clear to me that there's any significant differentiation. They're claiming lower latency, but until you see numbers, it's hard to validate that. On the switch side, they're supporting something called port-based routing, or PBR for short.
Got it right here.
There you go. Got your PBR. And that is something that was introduced in CXL 3.0, but really kind of actually made kind of fully specified in CXL 3.1. And so, most of the silicon out there today is kind of CXL 2 generation silicon, and they're talking about essentially CXL 3.x generation silicon. So there is some differentiation. The question is who actually wants that functionality, because in the meantime, basically companies are using extensions to PCI Express to do peer-to-peer fabrics, like Amazon running their Neuron Link protocol over the Astera Labs PCIe switches, or somebody using extensions on other PCIe switches, which have been proprietary, but have allowed people to do essentially peer-to-peer fabrics over PCIe. So it's interesting. I'm not sure that there's a market just yet.
Well, I think the key thing is, as much as Panmnesia talked about as being an innovation, the key takeaway I get from what you said is that it's actually standards-based, based on CXL 3.1. And so that's good. And then the other takeaway is the fact that you said these companies have adopted these workarounds. I mean, it at least proves the concept that people want like peer-to-peer access over, PCI or a similar fabric. So, I mean, this may just be the first implementation of a standard approach to something for which there is latent demand.
Yeah, I mean, in the meantime, though, UA Link came along and provided an alternative kind of peer-to-peer fabric, which is designed from the start to be more of a peer-to-peer approach, whereas CXL started off being more host-centric. So I think it'll depend on the use case, whether you want to go to a CXL fabric or a UA Link fabric. But for the XPU clusters, that's more of a UA Link application.
But if the idea is address memory, does UA Link allow you to address a pool of memory?
It doesn't specifically support memory pooling. So if what you're after is memory pooling, then CXL is the best fit. But if what you're after is sort of peer-to-peer access of memory that's spread across a set of XPUs, kind of in the same vein as NVLink, then UA Link is the answer, right? So that's the difference.
Or going back to Upscale, Skyhammer is the answer, because it has the memory type semantics. It's like it was really architected to allow one XPU to talk to the memory of another one without doing RDMA or more higher overhead kind of transactions, right?
Yeah, that goes back to the UA Link protocol. And then I think they're also going to support eSUN or Ethernet for scale up.
Thanks, Bob. It's been good talking to you.
Thanks, Joe. We'll see everybody next time.
Thanks for tuning in. Select one of these videos here or click the round icon to subscribe.
It's all about the Pentiums, baby.